Rust is type safe, memory safe, and thread safe, but that doesn't mean you can't have deadlocks or live locks or crashes. You absolutely can. The difference is that when a Rust program crashes, it's a clean abort. There's no chance of malicious code execution. The process just stops. In Rust, that's called a panic. There are plenty of things that can cause a panic. Integer division by 0, out-of-bounds array access, a failed assertion. We do our best to make sure these conditions can't happen, but sometimes they do anyway. In fact, remember println hello world? Well, it actually has a crashing bug. Welcome to Lesson 3, and thank you for supporting what I'm doing here. In these premium videos, I want to delve further into the practice of Rust, and today we're talking about panics. This might seem like an odd thing to cover so early on, but I have a few reasons. First, Rust's use of panics is an important part of how it achieves its safety guarantees. It's quite different from the C or C++ approach of letting you slide into undefined behavior if you index off the end of an array. Rust might seem somewhat panic happy, and I want you to understand what that means rather than being put off by it. Second, Rust's APIs are built to strongly encourage you to handle error cases. We'll get to proper error handling soon, but for now, the easiest way to get at the data you want is just to assert success. In other words, to panic if an error happened. And of course, that's fine when you're messing around with toy programs, so a basic knowledge of panics will help you get further in your explorations. Third, I want you to be comfortable writing unit tests right from the start. You've already seen tests that assert a function returns the correct value. I'm also going to show you how to write a test that checks a function panics when it's supposed to. And last, Rust is made for building robust software, and a proper understanding of panics and how to configure panic handling will help you when it comes time to build something for real. The key decision is whether your program should try to keep running after a panic, and the default setting might not be the most appropriate. This video follows on directly from video number 2, Hello Rust. And in that video, I left you with a practice exercise based on a factorial function. So we'll start by working through that exercise, and then we'll make it panic, and we'll take it from there. If you haven't attempted the exercise yet, now's a great time to pause the video and give it a go. The source code is at rustcurious.com/2. Now, I could do this exercise in the playground, but I'll do it on my machine so you can see Cargo and the basic project layout. Cargo is the build tool and package manager that comes with the Rust compiler. So I'll start by creating an empty project. Let's call it fact, short for factorial. So cargo new fact. We go into the directory that it's just created, and we can see that we have a cargo.toml, and in the source directory there's a main.rs. And in that main.rs we have a default hello world program, which is ready to build and run. So we can build it with cargo build, and that created an executable that's in the target directory under debug with the same name as the project. And there it is, it prints hello world. Now, like I said, this program has a crashing bug, because if I pipe its output to something that closes its input stream, like the echo command, we get failed printing to stood out, broken pipe. So if println hits an IO error, it panics. Now don't worry, there are perfectly reasonable ways to write to standard out without panicking on errors. And if you're working on something that might run disconnected from a terminal, then you'd use a logging framework instead of println. Anyway, we're here to do this exercise, so let's paste in the code. So we delete that, and we can run this as is. Rather than saying cargo build and then running the executable, we can do this in one step with cargo run. We can also run the unit tests with cargo test. Okay, and now to actually solve this exercise. So right now, factorial is a recursive function. Our job is to remove the recursion by rewriting it with a loop. So I'm going to delete the function body that's here, and we'll start with a mutable variable. Let's call it x. We'll initialize it to 1. And then we're going to iterate, we're going to loop, so for okay, so a panic can be generated by the compiler, like from integer overflow or indexing out of bounds, or it can come from library code like the unwrap functions, or we can explicitly panic using macros. But regardless of what caused it, what actually happens when we panic? Well, there are two options, unwind or abort, and you get to choose. Now, I don't just want to explain what those options mean, I want to show you. And for that, we need a program that spawns multiple threads, because the idea of unwinding a thread is that the other threads can continue running. So let's build a network service that uses a separate thread to handle each client connection. And we'll see if we can tolerate a panic on one thread without disrupting other clients. The purpose of this service will be to calculate factorials. It's called factd, and it's a PaaS, that's a panic as a service. It's tiny, the code fits on 2 slides, and if you'd like to run it for yourself, you can get the code from the same page as this video. Of course, this one doesn't work in the playground because it needs network access, so you'll need to run it locally. Now, we've only just covered the scalar types. There's a lot more to learn about the language before we can talk about threads and thread safety properly. But let's walk through this and I'll give you a brief explanation with the understanding that in future videos we'll talk in more detail about all the moving parts here. So we have 2 functions. The main function returns a result, which makes our error handling easier. This service will listen on localhost port 3000 for TCP connections. So first we create a TCP listener by binding to the port. And you might notice this question mark after the bind call.